Sawatom, who was a Taoist sage, once was seen to laugh to himself as he sat with closed eyes, and when asked why he laughed, said, "Just now in the monastery of Haiyin, 300 miles distance, there is a great feast going on. The priest stirring the huge kettle of bean gruel has tumbled in, but the others do not know this and are eating the soup." News came from the monastery later on that proved that what the sage had seen was actually true. Today, satellites are our eyes for distant vision.
Any aircraft campaign that NASA does needs to be strongly tied to our satellite observations, since that's job one for NASA, is to provide satellite observations for studying Earth science. And the stratosphere is one of the areas where NASA has a long and quite successful history in doing these stratospheric observations.
Satellites give us a global view and can make many measurements from space, but others can escape their scrutiny.
Our satellite observations can see these strong signals from the Asian monsoonal circulation. We've known about it there for many years, but it's a difficult altitude range for the satellites to get all the information you really need.
The really thin cirrus clouds will be transparent to a lot of satellite observations. And so, satellite observations are fed into weather forecast models as to give you the initial condition. But these cirrus clouds can act as a contaminant that may not be included in some of the cloud clearing algorithms you use there. So by making these measurements, we can constrain, just what these thin cirrus clouds are like and, the overall particle sizes. And we can feed that back to what the satellite is showing you. And we've actually developed an algorithm that can identify these thin cloud layers much, much better. And it's these measurements that help us validate these satellite retrievals.
Airborne campaigns collect data that can help scientists improve weather models.
So when we combine the satellite data, which gets you kind of large-scale picture of what's going on, combine it with the fine-scale features that we get from the aircraft itself, that really helps us to advance the science a lot. So that will allow us to look at the satellite data downstream and combine it with what we know about what's going on a finer scale from the ACCLIP campaign will help us to understand what's going on with the satellite data in the future and in the past.
There are processes in the atmosphere that are difficult to detect or measure from satellites. That's why scientists need to look closer in more detail. But how can they make these measurements?
Most people think of clouds near the ground, right? These puffy clouds, but cirrus clouds are very high. So we're talking 40, 50, 60,000 feet. The only way to make measurements there at those altitudes is with an aircraft that can fly well beyond the range of a traditional commercial aircraft.
And that's where our Dragons come into the picture.